When does automation become too unpredictable to trust? Engineers are trained to work with precision, systems that behave in the same way every time. But now we're asking them to adopt tools powered by AI, tools that are probabilistic, generative, and even a little opaque. On the show today, Stijn Jansen, co-founder of VIKTOR, joins us to unpack this tension. VIKTOR is a platform that lets engineers build their own tools, integrating BIM models and simulation software, and now even large language models that can generate code from prompts. The result is a hybrid workflow, part deterministic logic and part AI-powered flexibility. So how do we balance speed with confidence? And where do we draw the line between empowering engineers and abstracting too much? And what does engineering even mean when your tools are building themselves? Let's dive in. Welcome to the Structural Intelligence Podcast, the show where we explore the intersection of engineering, technology, and innovation. I'm your host, Owen Keenan, structural engineer, entrepreneur, and tech enthusiast. Each episode brings together innovators, experts, and thought leaders who are pushing the boundaries of what's possible in engineering and technology. Through deep conversations and practical insights, we explore how new tools, techniques, and mindsets are reshaping our industry. We hope you enjoy this episode. Welcome back to the Structural Intelligence Podcast, the show where we explore the edges of engineering and innovation. I'm Owen Keenan, and in each episode, I sit down with people reshaping how we work, design, and think. Today, I'm joined by Stijn Jansen, co-founder of VIKTOR, a company building tools that let engineers automate the boring and engineer the awesome. If you've ever juggled with Excel sheets, legacy software, and bespoke workflows, just to get through your week, this one is for you. We'll explore how VIKTOR is helping engineers build their own custom tools, what it means to create AI-ready workflows, and why domain knowledge is essential when building for the built environment. Stijn, welcome to the show.
Thank you, Owen. Really nice to be in the show. Thanks for inviting me.
It's great to have you. Great to have you. I've just gone through a little bit of an introduction for yourself, but I'd love to introduce yourself in your own words.
Yeah, of course. So I have an engineering background myself. So I studied aerospace engineering actually. I'm from the Netherlands, and I studied in Delft. Then I basically joined a small company after my studies. And also already during my studies, I became, let's say, also really fascinated. I really like engineering, but also by software development. So I learned some programming during my studies in different languages, but mainly Python. And then, the master track that I did during my my studies was, it was called knowledge-based engineering. So it was basically about, how can you use software to sort of bring all the different disciplines that you have in an aircraft design together. So think about aerodynamics, structural, all your control and simulations, basically. How do you all bring that together to actually design an aircraft? And there we did a lot with basically software to automate and connect all these different disciplines and analysis so that you can do an finite element analysis, but also in CFD analysis, etc. And there I really liked sort of that combination. Maybe I'm sort of the typical, also a bit the lazy engineer. So sort of automating your work. And when you're sort of, redoing repetitive work, I just got quite annoyed quite quickly. Sort of naturally, I always liked to see how you can do it more efficient by programming. And then I joined the company, and then we were basically just a bunch of young engineers, working, doing sort of small engineering jobs, but we were all looking for, let's say, really a scalable product. We did some physical things. So we had in the beginning also, we built pedestrian bridges, glass fiber reinforced pedestrian bridges. Then we sold that at some point, and then we started with VIKTOR, which is really, let's say, where automation and engineering, where we really bring that together.
Oh, that's great. I love the background of obviously starting the aerospace and working through, I guess, computational tools and other things like that. And having that background, I'm sure you were able to see a lot of the different efficiencies and other things from software, but obviously delving into the different coding and other things. So I'd love to get into that a little bit more. Talking to Victor as well, what's the platform, just for those that might not understand and know what it is?
Yeah, so what VIKTOR is, it's a platform with which we enable engineers to basically automate their work. How we do that is that within VIKTOR, you can create web applications. And in these web applications, you can build an interface. That's an important part. And in this interface, you can create all kinds of inputs and visualizations. But then we offer all kinds of integrations as well. So think about that you can integrate with BIM models, Revit models, but also with all kinds of analysis software like finite element analysis or with Excel sheets. And then you can basically also distribute this app. So once you have built the app, made the integrations, then you can share it within your organization so that also other people and your colleagues can use it. So really our mission is make it as easy as possible for engineers to automate their work and automate their workflows by delivering this platform.
Yeah, no, that's great. I sat down with a couple of your guys and we went through some of the builders and things, and I remember my experience as well being a structural engineer. I had a number of spreadsheets, one for like concrete design, one to do like piles, one to do steel, and then I had a bunch of different Excel spreadsheets where I'd dump in outputs from my modeling software in there, and I'd set it up in such a way where we would get all of the different outputs and then do the calculations and analysis. But that's a very interesting take. So from what I understand, it's engineers can build their own tools essentially, or applications, without having like a lot of prior software engineering knowledge. Would that be right?
Yeah, indeed. Yeah. So in principle, our platform is based on Python, which is already, let's say, why is Python so popular at the moment? It's because it's, let's say, a very, user-friendly or developer-friendly programming language, right? It's easy to read, so you can learn it fast. So that's what our platform is based on. We have all kinds of building blocks, but what we have recently developed is a way how you can also start with a prompt, so that you can just ask a question and that based on that it generates the Python code. So by that we make it, basically our goal is that where we mainly came from were engineers who were, let's say, could program in Python, that they were able to build apps. But now we see that we are coming to a point where also people who don't know Python yet can easily start with building apps on a platform.
Yeah, great. And so the platform really acts as an enabler for, like you said in the beginning, for people that might have prior knowledge for coding to set things up and allow it to have a bit of an environment and an interface where they can set up the tools. But now I'm assuming because of things like AI, generative AI and LLMs, that process has become easier and more accessible for those who can't code.
Yeah, indeed. Yeah. So we see that this technology, I don't know. Yeah, probably. Do you use LLMs yourself as well for coding? Have you played around with it?
I've played around with setting up a few different tools in things like Cursor and other like those sorts of, and they're really small type of like linear type of workflows where it's a quick data analysis or jumping into the Excel sheets and figuring out some of the defects or whatever it is. But it is interesting, like in playing around with this sort of stuff, like even in the last year, I felt like it's gotten a lot better. So it can actually pick up the things that usually would take me 2 or 3 times just to iterate over as well. So even for me, I've sort of, whether it be even smaller websites and other things like that, but really getting into those sorts of tools,
Yeah, so I think it's just amazing to see that it's just so much more accessible now. And what we often see also, okay, you're working as an engineer, right? You always have project pressure. And I think what we hear a lot, and also what I noticed myself, for example, when still doing engineering myself, you are always sort of under pressure. We hear a lot of engineers saying, okay, Python, yeah, I should really sort of try it out. And maybe you have engineers who learned, if you learn then in university, for example, then you're good to go, right? Then you already sort of passed this threshold often. And then you also see engineers just using it basically. But what you also often see, if you haven't learned it as an engineer, Python, for example, or programming, and you are under pressure, then yeah, you just tend to use the tools you know, right? So you're just going to do stuff in Excel, basically. That's I guess what people just do. And then I also fully understand that, right? Because when you then start with Python, it's not only sort of the let's say the syntax, so learning the language, but it's also, okay, you need to install it and then run it. And then, okay, then you also need some kind of IDE in which you write the Python code, right? So
environment, I've been through the whole thing as well.
Indeed. And then what I think is really powerful about Excel, it's sort of, you have your logic, but also you immediately have the interface of your tool, right? So and that's in Python, of course, different, because you basically just have your code, but you don't have an interface yet on it, right? So I think it's really logical that there are quite some, let's say, limitations, and then learning the syntax, etc. And now with these large language models coming, it's so much easier to go through this learning curve, because you can just talk to it and chat with it and say, okay, I would like to do, okay, this is my input data and I want to get this out of it. And then it just writes the Python, the piece of Python code for you. It even, what you see, right? It even uses Python often. So for example, ChatGPT or Claude, they all use Python already for some tasks. You see that often when you don't ask for them, okay, write Python code. You just ask, hey, I have this Excel sheet. Can you turn it into charts? Then it starts to write Python on the background already. And actually it's also showing it in the interface. Yeah.
That's an interesting point as well, with that there's almost this friction to necessarily start it as well. And you talk about the time pressures. You obviously have to invest in learning the syntax and other things like that. One thing I really liked about the VIKTOR platform was that it almost generates that front end, or in other words, the visualization, or the thing that you can interact with in the beginning, but also it's got the logic behind it, which is the back end, which powers the tool in and of itself. So you can actually have both, and it becomes like, for me, what really clicked is when I was shown the platform. It's like, oh, actually, this is sort of, it's easier to step into that as a domain expert, not having that background, but wanting to have that. And you probably, like engineers, I found anyway, that just want to experiment and work out stuff. They can figure out the logic of code, but they might not know how to write it necessarily. They can read it, but they can't write it or speak it. So I think it brings true to the motto of like, automate the boring and engineer the awesome. I like that from you guys.
Yeah, so that's indeed, I think that's been our slogan already since the beginning, so for 8 years or so. And that's really still, we are really happy with because it's that, right? So also as an engineer yourself, okay, what do you want to do ideally? You want to use your expertise to come up with creative and good solutions, right? And you also notice as an engineer doing your work, sometimes you just notice, okay, now I'm for example, things change again, some input change. You already thought about sort of how you came up with a solution, but then you need to change some parameters, rerun your finite element model, then update, I think also the flow that you just described, update all your Excel sheets. And then I think the most sort of painstaking part is when you then also need to copy paste, for example, tables in your Word report, which you then need to sort of, and then what I noticed also doing engineering myself is, that boring work is just, well, first of all, it's something that you at some point going to make mistakes because you're copy pasting stuff, you get bored, and then, but also you feel like, okay, now I'm not really using the expertise and the knowledge that I have as an engineer. I'm just doing sort of repetitive work. So that's really what we believe in. Okay, the more you can automate the boring work, the more time you can spend as an engineer on using your expertise, coming up with the right solution, and then it not only you have more impact as an engineer, but also your work is just more fun.
Wow. Yeah. That's that paradigm or concept of actually, okay, there are tasks that we do as an engineer that by natural measure, we just crunch out the numbers and crunch out these. And it's interesting with the advent of, say, artificial intelligence or intelligence on tap as such, that the lower order and menial tasks can allow us to sort of focus more on the higher level strategic / technical expertise type of thinking. And you wonder if I had 8 hours in the day and maybe 6 hours of that was spent crunching the numbers or going through and setting up sheets and getting everything ready. But if I had that 6 hours to make decisions on maybe 2 or 3 different concepts that might be better, and then I can run, instead of running just 2 or 3, I might be able to run 4 or 5 concepts that might be able to determine what we need to do. And I guess I'm talking off on a tangent, but I think looking down the line, it will actually enhance our sort of domain expertise, but it will enhance what we can do as engineers as opposed to just crunching the numbers.
And I think it can really help with finding the best solution, right? Because I think often you are not able as an engineer to actually, because of just deadlines and lack of time, you sometimes know, hey, maybe this variant will work better, but you just don't have actually the time to explore those, for example. And I think also there probably a lot of, let's say, material is wasted because you just don't have the time to explore all the options and all the variants. And there we see is, let's say, if you automate that process, what you basically at the end do is that you just drastically speed up the design iteration speed, right? So when all these steps are just integrated, and that means that when that design iteration is a lot quicker, then you can start to do way more iterations, basically, to further optimize your design or explore different things. And then let's say, and that is, I think, also super interesting to do as an engineer, that you are, sometimes you think, maybe this could work or this could work, and you don't have the time. But what if you could explore this, get insights in, hey, what actually happens? And then based on that, and make really a thorough decision on, for example, okay, what is the best design? And then taking into account maybe cost, but also nowadays I think things like CO2 emissions, those kind of things are also really important to take into account into what is the optimal design. Yeah.
That's right. Yeah. So there's a lot of different factors. I'd love to make a little bookmark for that for later in the discussion. But I'd love to just jump into some of the, I'm an engineer that wants to get started in these sorts of things. And I've talked to a lot of people. They're like, where do I start? What do I do? I want to automate this. Oh, I reckon this workflow could be better. And this is how I do it. Or I've got this calculator or this tool that I want to set up that is, that I just want to replicate and I want to share across the organization. If they were to jump onto your platform, where would they start? How would that work?
Yeah. Yeah, so literally at the moment, you can just start by prompting. So literally, we just have, like people are used to now with ChatGPT or anything. What you can actually just do is say, okay, I would like to build, a tool with which I can do this and this and this. So, for example, extract. I have this data. This Excel sheet with certain data, and based on that, I want to perform certain calculations, for example. And then what happens in our platform, that based on that prompt that you give, it generates the logic and the Python code, but also it immediately creates the interface of this tool. And as you had just mentioned already, what we have, let's say, all kinds of components with which you can make the interface. So think about that you can have all kinds of, let's say, input parameters and sliders, but also that you can upload files or that you can fill in tables. So actually, let's say all the input that you need in this tool. And then also it can show all kinds of visualizations. So think about those can be 3D visualizations, 2D visualizations, but also all kinds of graphs or maps or those kind of things. So it will just, from the prompt, turn this into your app, create the interface immediately. It all works in the browser, and also it creates the logic behind it. And then you can iterate on it. So you can further go with prompting. You can also edit. You will see the Python code. You can also manually edit the Python code. And then once you are, let's say, happy, then you can publish it in your organization or even publicly. That's also sometimes what people do. So you can make it a public app as well. But most of the times, engineers, distribute it in their organization. So then you can invite people to use the tools, etc., and start using it on projects.
Yep. What are some actual apps that people have built? Like, what are some specific type of things? Is there any cool different ways that they've used it? Have you seen?
Yeah. So what we see a lot is, examples? Let's say, one sort of there's quite a broad range. So it starts from simple tools, let's say replacements for Excel sheets. So for example, I have this norm. Maybe think about you need to do a concrete reinforcement check or some kind of these typical things you do as an engineer. Let's say some detailed analysis. What works, for example, really well is, let's say you have your norm. So some kind of, in Europe, we have the NEN norm, but it can also be, some kind of, what kind of norms do you have again in your area?
So it's sort of like, we call probably standards, Australian standards. They've got a set, say concrete structures, and then they've got a procedure to design a concrete beam or concrete slab, for example. Yeah.
Yeah, so what you could do is you could, for example, upload the standard and say, hey, I want to turn this into a tool. And then it will, and so the large language models are really powerful in that, and extracting then the right information and then turning that into a tool, basically. So while if you would do that with Excel, probably it would take you, depends a bit on, of course, the side, the complexity of the standard. But now this goes super fast. So this is one type of app where you can just say, has simple tools, but having the main benefit being that you can distribute it easily when you have an update of your, I think that's often quite painful as well, right? So when you have these Excel sheets, for example, in your company, people share them, but then at some point when you have an update, then how do you make sure that people are working with the latest version? Because everybody is sort of copying them in their own folder. So that's really, let's say, the main added benefit of a platform is that you can then distribute it in a way that you can release a new version as everybody is working with that newest version. So we sort of separated the logic from the data. So that's one thing. And then what you see is that it can go to very advanced tools. So maybe to give an example of a project on which our platform is used, it's the Fehmarnbelt link, it's called. It's a new, it's one of the biggest infrastructure projects in Europe at the moment. So it's a new tunnel between Denmark and Germany. and it's an immersed tunnel, so it's going under the sea. And it's an 18 kilometer tunnel, and basically this whole tunnel is made out of segments, and all these segments, as you can imagine, have all different boundary conditions. So because of the soil conditions, because they are submerged in the soil, but also because of the depth and because of the loads. So all these elements, I think there are 90 elements. They needed to be designed separately, but then also, well, you know, your structural engineer yourself, also you need to take into account all these different load combinations, etc. So basically they had 10,000s of finite element models to cope with all these different segments and all these different situations. And at the end, as you can imagine, the amount of concrete and steel reinforcement in those elements, that's just, I think the amount of steel reinforcement is 50 Eiffel Towers or so. So you can imagine that you really want to optimize this, right? You don't want to say, okay, we just take the segment with the biggest loads, and then we just apply that reinforcement to all the segments, because then you just, just have unnecessary reinforcement. So they built an app with which they could, they automated this whole process. So they have all the input, and then they could optimize the reinforcement of all these segments automatically by automatically generating all the finite element models, optimizing the steel reinforcement, and then also doing all the concrete checks. So the full, let's say, structural analysis process was fully automated in this application. And then it was also basically coupled with the BIM model, etc. And by this they were just able to, it took, of course, time to build it, but once they built it, they were able to just do this, in where it usually took them months, basically, to design one element. They brought it back to that they could do, I think, the whole tunnel in a few days now.
Oh, wow. Well, there you go. I love those two examples, because in my everyday work, I see probably those examples come, and like I often just need to do a simple beam calculation, and it's got inputs and it's got outputs that I need to make a judgment call on, and I know that, okay, I'll verify the inputs. Okay, this is the geometry. These are the loads. This is how I need to do it. These are my design actions, and I'll just put it in a list form and plug it in there. And then in my current calculators, whether it be my Excel spreadsheets or I've got another software that's already got calculators set up and I plug it in there, it will give me my capacity. You know, it's 50% of capacity or 60% of capacity, and those checks are to code. And to your other example is, I really like that, because that's a very bespoke, very specific application that, say, a software company or a construction company doesn't have the time necessarily to invest in developing a whole software to do that. But it will probably know the general geometry and shape and the different parametric things that would change, but things that will also stay the same. But things, and then the variables and the logic can be in there to make sure that, okay, you're actually designing these things efficiently as well. And then again, you've got an input, and then you've got an output, which you can make a judgment call on to move forward on, which is great. One thing that I think may be a hesitation for a lot of engineers is trusting the black box. They love the black box analogy in terms of transparency and other things like that. And particularly with LLMs and things like that, I think I've heard a lot of reservations from people that go, oh, I've prompted ChatGPT and it's useless at calculations, or like even the thinking models, they don't do it properly. And look, I would have to agree with that, but it's a different, like, your platform is different. Like I find it quite interesting is you're actually building the tool that potentially has transparent logic. But how would you address that to somebody that's like, oh, I don't know if I trust the tools? How would you?
Yeah, so I think that's a very, let's say, if engineers don't ask that question, then then I sort of, let's say that I find it really logical that people ask this question, right? And that's also what we learned as engineers, to be sort of very critical and understand what's happening. And I think this is a very important point also with AI, because at the end, right, by, let's say, design or definition, these large language models are probabilistic, as you could say it, right? So basically, the way that they are set up is that you know that with the same input, they will not give the same output, or they will not always give the same output. That's the whole concept of how they work, which also makes them really powerful. Because of that, they can do these sort of creative things, right? Or generative things. But let's say if you look at engineering, so let's say if you use them to generate a piece of text for, I don't know, to put a post on LinkedIn, you can check it and it doesn't matter that much. But let's say if you are designing stuff based on a sort of a probabilistic way and it hallucinated maybe some kind of calculation, this is just totally unacceptable, of course, to base your engineering on that. So how we look at that is that what you do within our platform, within VIKTOR, is that you use AI to generate the Python code, which is then a deterministic tool, right? So you know that once the code is generated, then you know, okay, with the same input, I always get the same output. And so that's how we think it's sort of best of both worlds, in the sense that it can help you to generate this logic, and then you can review the logic. So you will see just the Python code. It's, I think, in general, really well readable. Also, if you don't have any Python knowledge, personally, in my opinion, I also used to do a lot with Excel. I find a line of Python code, more easily to read than, let's say, a formula in Excel where you have 20 brackets and A12, whatever. So I think sort of reviewing Python code, of course, you have to get used to it a bit, but it's really well readable. So then you can take the step. Okay, now I can check what happened. I can also check it with all kinds of benchmark calculations, for example, and then based on this, I publish this app, which I make available, and then you know for sure after that, okay, with the same input, I get the same output.
Oh, that's it's conceptually, I think that's really important, because I think the distinction needs to be made from non-deterministic or probabilistic use of artificial intelligence or AI or generative AI, and also the tools that we use to facilitate our engineering as well, which are deterministic and have specified rules and logic associated with them. And I think sometimes those lines are maybe blurred in some people's minds, but like what I've found recently is that there is power to use what the LLMs are really good at, which is generating and being able to describe in natural language the things and that you want to achieve and the logic that you want to achieve, and it will capture that. And because it's probabilistic, it'll probably do a fairly good job, but it won't be the same every time. But it gives you're not starting from absolute zero. So like with the apps that you're building, I mean, you can build this app just like you do an Excel spreadsheet, for example. You can spend hours and hours making sure that it's in accordance with the concrete design code. Okay, that's correct. It's been checked by another engineer. We've run cases on it. It's been checked. We know that everything is there. Then we submit that and publish it as the verified sheet, and you're only allowed to use that sheet. Basically, we've got a bunch of AI interns now that are spinning up these tools, which number one, we still have to check. Number two, we still have to verify. And then we've got some sort of version control around that deterministic input and output. So the trust is built from a verified source. That's sort of how I see it.
Yeah, exactly. So I really like this metaphor. It's exactly how I see it as well, right? Because let's say in our practice, I think we have these kind of things in place, right? It's the same that if you indeed ask maybe a junior engineer or also whoever, it doesn't even matter, but we always have these processes in place of reviewing, right? Because also people can make mistakes. So that means that if you say to someone, okay, can you create this? Then there's always a sort of a 4I or even more principle of, okay, let's review it and then do it like that. So I think also that's how we should look at AI as well. Okay, it generates something. Indeed, you review it in your process. At some point you say, okay, well, this is correct. And then, it goes into, let's say, then you can use it in a project, for example. And what I also find, what I was thinking about what you were just saying, what I also see as a very large benefit of, let's say, Python code compared to Excel sheets is unit tests. So this is something which is, maybe not everybody is familiar with this, but let's say what you often see is, okay, once you indeed have this Excel sheet, what do people often do? They say, okay, I just know with this input, I expect this, I don't know, unity check, for example, right? Or this, I know with this, I have my beam calculation. I know with this load and this span, my deformation should be this number because I did this in a hand calculation, and then you're going to check, okay, is it actually correct, right? And then, okay, then you do an update of the sheet, and then people are sort of, okay, now let's fill in my case again and see if it gives the number. Well, I think this concept in software engineering, the concept of unit testing can really help with this, where you say, okay, I describe these test cases. So basically, okay, with this set of input, I expect this output, etc. And then you add that to your code as well. So you say, okay, so that means that how this unit testing works is that when I do an update of my code, basically all the tests are run, and you just immediately see, okay, are they still all correct, or did I change something? And by adding that as well, I think this is such a powerful concept for engineers, where you know then, okay, maybe you're going to change your code, or you think, okay, maybe I can just optimize the bit, or you're changing something. By then running all those unit tests again, then you know for sure, okay, it does what it should do. And this is something that we support in our platform as well. You can add these unit tests as well. And then in this way, you can be way more sure of the quality of the tool that you're developing.
So just to sort of round out that conversation, it went from skepticism about the tools, but when we sort of define the workflows and how we're using these type of things, which is the non-deterministic probabilistic LLMs to generate, plus the tools that you're actually generating, and then in the end, there's verification procedures around that with your unit testers and other things like that, you actually get a better outcome from my perspective anyway, as opposed to copying and pasting the old Excel spreadsheet, and that's what we call it. But so going to that, so understanding, okay, you can generate the tools, you can verify the tools, and then you can use the tools for our applications in what we do. One thing I really wanted to dive into was, okay, cool. We've got these tools now. I got a hammer, I got a wrench, I got a thing for different purposes, right? I can now use these, but these software tools can integrate into different things. You mentioned that at the start. You might have your structural analysis software, you might have your output software that you need to sort of come through. Could you describe what integration is and how that works, and what sort of types there would be, and maybe some examples we can dive into as we discuss this on some of those things?
Yeah, good one. Yeah, so I think indeed this is a logical next step that you talk about. So one thing that we often see, then you start with, let's say, creating these tools as sort of also modular blocks, but then the next step is indeed, okay, how can I sort of integrate this workflow? So let's say, to give an example, you are designing some foundation with piles, for example, and there are, maybe take an example of, to make it really concrete, you're designing a crane foundation, which is just a concrete slab with some piles. If you look at that, then you have all kinds of steps where you probably have some kind of, maybe already a BIM or a Revit model, for example. Then you need to do your structural, you do a finite element analysis on this structure. Then there's also some geotechnical analysis that needs to be done, right? What is, let's say, the bearing capacity? So what often, it's often the case that, let's say, that also a geotechnical engineer is involved to do this. Then you get your, let's say, all your stresses from your finite element model or your sectional moments, etc. Then you have an Excel sheet, for example, or something else in which you then do the concrete checks, and then you create your reports. Well, it could be that you already created some tools there. Let's say, to do the concrete check, for example, that you have already a tool for that. Let's say it's a VIKTOR app. But what you can now do is that you can, in our platform, you can fully integrate this whole process. So think about, you can, for example, start with, maybe you often, as a structural engineer, you get, there's a Revit model that you use as a basis to do your structural design on. What you can literally do in our platform is that you connect it to, let's say this model is on Autodesk Construction Cloud. You literally connect it to that and you say, okay, just fetch this model and then retrieve certain information from it. So get all my primary structural framing from that. Then based on that, you can add extra, for example, parameters. So you say, okay, these are the loads that I have. So these are my crane loads based on that. Or maybe you even can select, you already created the library with different crane types. And then you just select the crane type and then you have already your, let's say, all your loads. And then based on that, we have an integration. Also, you can connect with your local software. So, for example, you're doing a finite element analysis in ETABS or in whatever, and then you can actually automate the process of creating that finite element model based on that input automatically, run it, getting the results back, and then putting those results again. You can also just integrate an Excel sheet if you would like to do that, and running the numbers there, getting that input back. And then we have all kinds of tooling also to do, for example, to create reports, so that you use some kind of Word template and that you then put all the data and information automatically in that Word template. So in this way, you can fully connect such a full workflow.
That is so interesting. And what you begin to realize is that, okay, that it is workflow based, isn't it? And typically a lot of these things are fairly siloed. Not all the time, but like I remember just going, okay, cool. I've got my Revit model and I have to like transpose it into my structural model. And then, okay, cool. I've got my loads now. I'll copy and paste my Excel spreadsheet or my CSV into my Excel spreadsheet. And then I'll check my piles for concrete. Okay, cool. And then I'll check my piles for geotechnical capacity. Okay, cool. All right. Now I've got my geotechnical capacity. I need to put it into my design report. And so that whole process is obviously a workflow. Each one of these are modules, right? Here that you can think about it. And then each connection is an integration, right? And so I think for me, I really sort of clicked with that, is that a lot of the tools that we find today are sort of legacy type of tools, in the sense of they're not AI native in a sense. And I mean, we've talked about workflows and automations, but it's sort of not automation type of native as well. So they've got their own platform, but they don't have the necessary, say, connections that can come in, whether it be through APIs or other authentications into that. And because of that, there's a lot of manual input and output because of it, which is such a really interesting point that you mentioned. And so we're now graduating, like, in thinking about the concept to go, okay, cool. We've got intelligence on tap, or AI, that can assist us to generate the tools, that the tools, verified and deterministic, can do my calculations as I give it the right inputs. It will give me the right outputs. And then now I can then connect that through my workflow to eventually give me the outcome, whether it be the design of the drawing, the design report that I need to do, and the decision that I need to make. So always at the end is the engineering judgment, is the decision. Everything before that is a workflow and a calculation. That's what I sort of see.
Exactly. Yeah, and I think it's also indeed the case that you describe. I think let's say if you only would need to go one time through this workflow, it wouldn't be so painful, right? You just one time need to copy paste your results to your Excel sheet. But what happens in practice when you are working on this project, I think little times it's just one iteration and it's done, right? Because everybody's working in parallel. So I think when this becomes really powerful, once you sort of set up this workflow and you automated this, when there's then an update of the Revit model, for example, or maybe we will use another crane than what we thought initially. If it's then just a matter of, okay, the Revit model is updated with one push of the button, you can run the whole flow again, check, okay, are all my Unity checks in place? Okay, maybe I can optimize something because I have a lighter crane, maybe the path can be a bit. But if you can just go through this process super quickly, what you can also add for that, Python is also really powerful. Next step is that you use sort of optimizations on that, right? So that you say, okay, automatically look for the pile with the minimum depth that complies with all my Unity checks, or all those kind of things you can build on there as well. And then it just becomes super powerful. And just one other thing that I would like to mention here is that, let's say, I think what's really important here is that there's a lot of people talk about, for example, okay, how can I couple my finite element model with my Revit model, and how can and then okay, I can just import my Revit model in my structural analysis package or whatever. But there's always some translation step in between, right? Or let's say, typically in your finite element model, you need boundary conditions and loads, for example, which are in general, I think, not. Yeah, that information is not in your Revit model typically. So how we see this is you have these modules and you sort of connect them, but what's really important is that you need to be able to make some custom logic in between those modules, right? Where you say, okay, I retrieve my structural framing, well, then I have my geometry, but then I need to add some loads and some boundary conditions and maybe material properties, which are not in my Revit model. And then based on that, I can actually automatically generate. And the same holds for, okay, when then I have my finite element model, I don't do, let's say, the reinforcement checks for all the sections. I just look for sort of my governing moments, for example, and that's a piece of logic where you say, okay, first I will determine the governing moments, and then based on that I will do my reinforcement checks, for example. So I think that, let's say, putting that logic in between and being able to do that is really essential to automate this such a full workflow.
That's you almost become the architect of the workflow. And getting a bit of an understanding of like how things connect. And one thing that I've really gone through in my automation journey is the fact that, okay, I actually need to figure out the way I think, because I actually do these things intuitively. Like I will connect my Revit model to my structural analysis model and take out the things that are relevant without thinking, I suppose. Like it's obviously thinking, but it's an intuitive decision to come back and forth to that. So really, to your point, I think there's such value, and it becomes quite powerful when you can actually realize, okay, even if I want to make a simple connection, you can speed up that iterative process. And I think in the iterative process, that's really where we become, where we shine as engineers, and we can make the judgment calls on what's the most optimized and things like that. That's our discipline is to make things most efficient. I'd love to dive into maybe the last bookend, which like I've been pondering on a little bit, is we talked about non-deterministic, like probabilistic, which is the AI, say, and then the tools. One thing that I've really seen lately is that, okay, I can talk to ChatGPT and try and get it to do my calculations, but maybe that's the wrong way to think about it. But what it can do is it can actually use its judgment calls to then use the deterministic tools to its disposal to then make an iterative case or a calculation as well. And so using your crane example, like this is probably what I'm thinking anyway, is that, okay, so you've got 3 different types of cranes and you want to figure out what the most optimized foundation would be based upon those 3 cranes. And so where it then comes into play is that maybe an AI agent can understand, here are all the edge cases, here are all the use cases. Use these tools to help me to make a decision of what the best case would be. And because you've set up the workflow in such a way that it's not just one engineer trying to plug away the numbers for the different cases, they can run it in the background. Do you think that's possible? Like, do you think that's eventually where it's going to go? Or?
Yeah, I think so. I think indeed, I think there are some steps to take before we are there. And we have been exploring actually these kind of things already quite a bit internally. But personally, I'm very well aligned with what you are saying here, is that this is, I think, where the future will go. Because that, let's say, where you can indeed combine the let's say the power of the deterministic tools, or the necessity actually, in combination with sort of AI, where an AI or large language model can indeed use a deterministic tool that you have created, and that it then basically sort of orchestrates this. And then also there, I think it's possible to make this really transparent, where basically the LLM can say, okay, I called this tool, I used these input parameters to call this analysis part, and I got these outputs back, basically, which you can then also say, okay, which you can then also verify, etc. So I indeed totally agree where, this is, I think, also where we can get going. And then, let's say, you can really see this agent as maybe then it then turns more into a colleague, right? So that you can ask this is also something that you would have with a colleague, right? So let's say you have your colleague and you're looking together at the design, and then you think, hey, maybe you should try running, maybe it's an option to use different types of cars. So can you do those calculations as well, or right? So that you can actually, and then actually that colleague starts to do that, right? It starts to sort of change different things, and then coming back, and then you discuss it again. And I think definitely we could, this is where you can go, where you can actually in natural language then ask, hey, maybe you should try to do this and this and this. So 100% agree on that. And I think in general, if you look at the model now of tool calling is something which is, and you have MCP as a development, which it's a bit of a technical term, but this is really all about what's happening in the development of AI and large language models, where actually you allow large language models to do tool calling, which is literally, okay, maybe fetch some information from an API or whatever. So it also really fits well within this framework.
Yeah, and look, it's super exciting, I think, and just to conceptualize and think through maybe some of the things on how it's going to go, particularly with our engineering workflows, is really I'm really optimistic about it, to be honest, and I think it's going to lift our game in a lot of ways as engineers. And I think we'll need more engineers as well in that sense to be able to orchestrate, architect, and really bring together these things. So I wanted sort of, I know we've gone sort of full circle here, and we've taken ourselves on a journey of, cool, we're setting up our tools and how does that work, to maybe some of the bigger picture thinking. But to round us off, I'd love to hand it over to the AI host. So basically, I'm just going to get it to take over for me for the last question. And it's going to ask you a question, and then it's going to round us out. And then I'll get you to, if you have any final words after that as well. So I'll do this now. All right. I'll hand you over now to the AI host.
Of course, taking it from here. Sometimes the most powerful shift in engineering is about transforming the familiar into the customizable. Our chat with Stijn Jansen highlighted how giving engineers the tools to automate their own workflows is a game changer. Instead of just relying on off-the-shelf software, they can craft solutions that fit their exact needs. Now, Stijn, considering all the ways engineers can now take control of their workflows, what would you say is the next big step for those who are just getting started with this kind of automation?
Yeah, that's a great question. Yeah, so I think it's just playing around with it. That's okay. Maybe it's sort of a cliche, but I think that's just so. Yeah, that would be really my advice. So to just start to play around with these kind of tools, and yeah, I think we know that technology, is there to indeed greatly impact our work. So I think it's just, and also I think already, well, I can, of course, it's a bit promotion of VIKTOR, but really, I can really recommend also to play around with our platform and our app builder. You can just create a free account, and then you can just start prompting. And what we see and what we heard back, you can just now with these technologies, it's just so quickly you can get value, which makes the whole, let's say, at the end, automation is a business case, right? It's just like that. So you just look at, okay, how much time does it take me to automate it, and how much time does it save me? And this whole with this new technology and with AI coming up, this business case, because let's say the time that you need to invest is so much less, this business case becomes just so much more profitable, let's say. So I would really recommend people to just start to play around with all kinds of these tools. Think about, I think what's really important, that you think about a clear case where you say, okay, what am I doing? And then it doesn't have to be, it can also be just something boring, indeed repetitive, where you say, okay, this is just frustrating. Not immediately start with, okay, completely automatically generate my full bridge design, go, right? But start with something small where you know there's friction and what would help you if it's automated. And then, use that to see if you can automate it. Because what I really believe, also coming back to what you just said about, let's say, more engineers, but I really believe that we as engineers have a very crucial role also in the world at the moment, right? We have huge challenges in terms of, all the stuff that needs to be built. We need to do this in a sort of a sustainable way in some way. We know there's a lack of engineers in the world. So I think it's really also our duty to become way more productive as engineers, because we play in my opinion, such an essential role in crucial challenges that we have in the world. So hopefully we can really push forward and drastically become more productive, by that having more impact as engineers.
Stijn, it's been a pleasure having you on today, and I've really enjoyed the conversation. Just thinking about the flows, thinking about sort of where it's going, but also thinking how easy and accessible it is for engineers just to grab it and go with it now. And particularly through your platform like VIKTOR and others such as that, I think there's a great opportunity here. Is there any final words that you want to share with us?
So thanks also a lot, Owen. I really enjoyed this conversation as well. And thanks for inviting me. Maybe if people would like to get in touch, if you have any, because I'm always very open to get in touch with people who are also working in this field. So feel free to connect to me on LinkedIn. And of course, if you have if you're trying out a product and if you have any feedback, please let us know, because then we can use that to further improve. That's all I have to say.
Yeah, no, that's great. And we'll link everything down in the show notes as well, and links to Stijn's profile and also VIKTOR and other things as well as examples. But again, we really appreciate you having on. So just to round us out, if this episode got you thinking differently about how we build, automate, or work in engineering, we want to hear from you. Connect with me on LinkedIn, and don't forget to check out VIKTOR. We have links in the show notes. And if you enjoyed this conversation, please share it with a colleague, subscribe for more episodes, and exploring where engineering meets innovation. Thanks for listening, and I'll catch you on the next one. Thanks.